All right, guys. So, talking about endocrine responses and adaptations to anaerobic training, general overview. Hormones produced from the endocrine system play a major role during exercise and aid in keeping the body at homeostasis through multiple different specific functions, specifically focusing on development of muscle, bone, connective tissue, just tissue growth and remodeling in general. What are we going to talk about? Acute changes during and after exercise, chronic changes in the acute response to exercise, chronic changes in resting concentrations, and then finally changes in hormone receptor content. Acute anabolic hormone responses, so this would be during, post exercise, elevated testosterone, growth hormone, and cortisol for up to 30 minutes post exercise in men. Again, during and post, greater elevations are seen with larger muscle groups, lower body, leg day, etc. Right? You're going to be utilizing larger muscles, compound lifts, etc. Higher intensity exercise as well. Shorter rest periods is another variable there that we see greater elevations in hormone responses. Um, Generally speaking, hydrogen ion accumulation is the most likely factor that influences growth hormone and cortisol release. Free testosterone has a greater increase from resistance training compared to aerobic training. So again, heavy lifting, resistance training is going to be more beneficial for these specific anabolic hormone responses compared to something like endurance training. The acute response from anaerobic exercise is critical for physiological adaptations. Insulin-like growth factor is a primary mediator to growth hormone, and it's stimulated post-anaerobic exercise once again. Catecholamines like dopamine, norepinephrine, and epinephrine are also increased, and these actually aid in performance, especially with resistance training. So our force output, production, fatigue resistance, all of these, again, epinephrine, adrenaline are going to be helping us perform in the gym or given any specific exercise. So, chronic changes in the acute hormonal response, adherence to a long term resistance training program does result in increased ability to exert force. These occur through both tissue growth, which is primarily mediated by hormone responses. Again, increases in growth hormone are also improved over time with adherence to that resistance training program. Overall, the endocrine system has an increased ability to tolerate the stress of anaerobic training. So we're able to tolerate more from a physiological perspective in terms of volume with specific resistance training. Chronic changes in resting hormonal concentration. This is pretty simple because resting hormone levels, hormone concentrations are not likely to change from anaerobic exercise. And this makes sense. Honestly, it's better that it's that way because the increase in hormone concentration during and after anaerobic exercise is sufficient, to stimulate tissue growth and remodeling without the need to chronically change basal hormone concentrations. And honestly, we wouldn't want this because on paper it sounds great, higher levels of, let's say, testosterone and growth hormone over, as we increase, we get more testosterone as we're getting stronger and everything. But if our resting hormone concentrations were higher, it would likely lead to a downregulation of those receptors, eventually sort of negating any potential benefits from that increase. So generally speaking, resting or basal hormone concentrations do not change from chronic anaerobic training. Hormone receptor changes. Receptor content is important for adaptations elicited by hormonal responses. Androgen receptors, one of the most important for tissue growth and remodeling, depends on the muscle fiber type, contractile activity, and testosterone concentration. Resistance training does upregulate androgen receptors 48 to 72 hours post-workout, which is great because we're also seeing these increased hormonal responses around this time. But one thing to note is that androgen receptors are initially downregulated post-exercise, and it's further downregulated with more intense exercise, more volume, etc. But they do rebound and upregulate following this. Again, up to that 48 to 72 hours post exercise, where we're getting an upregulation of the androgen receptors. And it should be noted that consuming protein both before and after exercise consumption can decrease the downregulation of the specific androgen receptors. Thank you.